Welcome to Pindar Poetry. We hope you learned something new.
You start by capturing a clear baseline so you know what to fix. Run a 1 5-minute ping trace and record average, P95 and P99 latencies. This quantifies the spike. At the same time, collect CPU, GPU, memory, disk I/O, and network TX/RX metrics to correlate resource pressure with latency. Then inspect the model serving config, batch size, concurrency, and timeouts because misconfigured batching often causes sudden spikes. Once done, mark timestamps so you can map metrics to each spike event. Now you reproduce the spike in a controlled environment and change one variable at a time. Run staged ramp tests while toggling batching and concurrency. Test single request mode to see if batching introduces latency, then reintroduce settings progressively. Simultaneously, verify network health. Look for packet loss, retransmits, MTU mismatches, and DNS resolution delays because transient network issues amplify tails. If GPUs are used, confirm context switching and memory copies aren't stalling. Make sure to capture logs and traces for each run to compare. Apply the targeted fixes you identified. Reduce or dynamic tune batch size, cap concurrency, enable sensible request timeouts, and prioritize CPU/GPU affinity to prevent context thrashing. Once applied, validate by running a 30-60-minute peak load test and compare P95 and P99 latency to your baseline. Look for steady tails. If the spike persists, collect flame graphs and distributed traces to pinpoint blocking code paths, then escalate to the infrastructure team with logs and timestamps. One tip: reproduce failures with full tracing before making more changes.
Thanks for watching. Consider subscribing if we helped you.